We'll look at some examples of finding probabilities using a binomial distribution. And this example is from this task. So a fair die numbered 1, 2, 3, and 4 is thrown 7 times. Find the probability that an even number is obtained exactly 3 times. So I'll show you how you can do it by hand, and we're going to look at how to use technology as well. We can start by establishing that this is a binomial distribution. We can use the binomial model because we have a set number of trials. We have 7 trials, and the probability is the same each and every time. So this is a 4-sided die with the numbers 1, 2, 3, and 4. And we're throwing this 7 times. So if we're going to model this binomially, we have that let's call this variable e for even. So the variable e is distributed binomially with the parameters 7 and 1/2, like this. Just a reminder that the general form of this is that x is a random variable distributed binomially with the parameters n and p, where n is the number of trials and p is the probability in each case. And now our job is to find the probability that the random variable e is equal to 3. And that's because e can take the values. If we think of e as a set, it can take the values 0, 1, 2, 3, 4, 5, 6, and 7. But we're interested in the probability that an even number is obtained exactly 3 times. So that's why e is equal to 3. And now we're using the formula on page 350, the one that looks like this, but we're going to put specific numbers inside here. So this is the formula in the general form, and that's the one we're going to use. And we're also combining it. We're combining it with the formula for finding the probability of a random variable, which looks like this. Oh, I can't fit it all in. Yeah, this is on page 351. So we start here by saying that this probability is equal to 7 chooses 3. This is how we can read this. And then I'm going to write 1/2 to the power of 3 multiplied with 1/2 to the power of 7 minus 3. I'm going to explain what I'm doing here. So the 7 here, this is the n that we have over here. We've decided that this is a binomial distribution where you have an experiment with 7 trials, and down here is the amount that you're looking for. We're looking for probability that this variable is equal to 3, that this happens 3 times. And the next bit is the probability that we have up here. That's 1/2. We're going to put that in here. And this is to the power of 3. Multiplied with 1 minus the probability. So 1 minus 1/2, that's going to be 1/2, to the power of n minus x. And the n, that was 7, and the x, the value that we're looking for, is 3. So again, this is going to be equal to, and now we're going to exchange this bit with this expression here. So that means that this c here, we're going to translate that into 7 factorial divided by 3 factorial multiplied with 7 minus 3 factorial. And then we're going to multiply it with, 1/2 to the power of 3. That's going to be 1/2 multiplied with 1/2 multiplied with 1/2. That's 1/8. And then we have 1/2 to the power of 4, which is 1/16. But we'll see what happens here then. So this is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1 multiplied with 4 factorial. 7 minus 3 is 4 factorial, which is 4 times 3 times 2 times 1 multiplied with 1/8 multiplied with 1/16. And you can see what happens here is we can just strike out these 4 factorials against each other. And down here, 3 times 2, that's going to be 6. So we can strike out the 6 as well. This is gone. And that means that we're left with 35 divided by 8 times 16, which is what, I don't know. But if you work this out on your calculator, you'll get the number 0.273. And this is the probability that we're looking for. So the probability that an even number is obtained exactly 3 times if you roll this die 7 times is 0.273 or 27.3%. And the next video will show how to do this on the calculator.